Hello student, myself Digan Sakhiwala. I am your math sir. Today we will start chapter number 1, real numbers. Dear student, in this topic we are going to learn about the lemma algorithm, Euclid's division lemma, Euclid's division algorithm, fundamental theorem of arithmetic, HCF, LCM, that is highest common factor, least common multiple, and the irrational number. Dear student, in the lower standard we learn about something like how to find the highest common factor, as well as we learn about the LCM, that is called the least common multiple. So we take one example here. First example, in that we take two number, one is called, we can say that 14, another number we take the 12. So we did the simple procedure that 2 7s are 14, 7 7 1, like that we were doing. And here we are doing the 2 6 are 12, 2 3s are 6, 3 3 1. Now whenever we have to find out the HCF and LCM, then we are writing here 14 equals to 2 into 7 into 1. No need to write 1, it is your choice. 12 we can write here 2, 2s are 4, 3s are 12. Whenever we are finding the HCF, then we find the common number, that is 2 and 2. So this is common, so HCF is 2. Whenever we are finding the LCM, at that time we are finding the all the numbers. So here 2 is repeated 2 times, here 2 is repeated 1 time, so 2 is repeated 2 times, so we are writing 2 into 2, okay, 2 into 2, 3 is there and other is 7. So 2 2s are 4, 4 3s are 12, and 12 7s are 84. So HCF we get 2, LCM we get the 84. This is the simple method we used in the lower standard. Now same technique we will use to find out the HCF and LCM by the Euclid's theory as well as by the simple way. So first we will understand what is called the lemma. A lemma is a proven statement used for the proving another statement. Okay, so when we have to prove the one statement, then we use another proved statement, that is called the lemma. Algorithm. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. So we have any type of problem, are there, like we have to solve the LCM, we have to solve HCF, or we have to repair our computer, or we have to cook the food. At that time we make the step, okay, meaningful steps we make, and that meaningful steps are called the algorithm, or we can say that it is a procedure to solve the problem. Euclid's division lemma. Before understanding the Euclid's division for lemma, first we will understand simple division. Suppose I have two number are there, one is 15 and other is 2. In that 2 is called, we can say that 2 is here divisors, 15 is called the dividend. So when I do the division, then 2 7s are 14. So 15 minus 14 1. So here I get the 1, that is the remainder, and 7 is called the quotient. Now same thing I can represent by differently by the Euclid's division lemma. Okay, same thing we will represent in different way, but it is same only. For any two given positive integers a and b, here we take the a as 15 and b as 2. There exists unique whole number q and r such that a equals to bq plus r, where 0 is less than or equals to r less than b. So here the b is, here we can say that 2, a is 15 and q is what we get 7, and r we have the 1. So we can represent this number in this way: a equals to bq plus r. A is the dividend, that is 15, b is the divisor, that is 2, quotient is 7, remainder is 1. So we can write 15 equals to 2 into 7 plus 1. Same thing we represent like that. Same way, when the 18 is divided by 2, then we get a is greater than b, so 18 is greater than 2. So 18 equals to 2 into 9. 9 is here, we can say that quotient. 2 is the divisor, 2 into 9, there is a no remainder, so 0. Same way, 17 divided by 3, then we can write 17 equals to 3 into 5. 3 is called the divisor, a is called the dividend, and 2 is the remainder. Okay, Euclid's division algorithm. Euclid's division algorithm is a technique to compute the HCF of two positive integer a and b, in that a greater than b, using the following step. So simple thing is that we want to find out the HCF or LCM between the two number. In that condition is a greater than b. Okay, so that we can find by the Euclid's algorithm or Euclid's lemma. Okay, how? Before that we already learned this thing in the lower standard. Same way we will find, but the condition is different. So step 1 is applying Euclid's lemma to A and B, that is find whole number Q and R such that we get A equals to BQ plus R, where 0 is less than or equals to R less than B. Okay, R is here remainder and B is what here divisor. Step 2, if R equals to 0, then B is the SCF of A and B. So you can see that if the R equals to 0 in this condition, when 18 divided by 2, then R is 0, then the 2 we can say that is the SC of A and B. If R is not equal to 0, apply the Euclid's division lemma to B and R. Okay. Step 3, continue the process till remainder is 0. That is, repeat the step 2 again and again until R equals to 0. Then the divisor at this stage will be the required HCF. Continue the process till remainder is 0. The repeat step 2 again and again until R equals, then the divisor at this stage will be a required HCF. Fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes. Okay, prime means those number are there which has factor 1. Okay, so every composite number in what they have the one another factor including the 1. Okay, expressed as a product of prime, and this factorization is unique apart from the order in which the prime factor occurs. So HCF of A comma B equals to product of the smallest power of each common prime factor in the number. Okay, now we are going to find the HCF of 12 and 16. Simple way we will find here. Okay, so we will write here 12 and here we will write 16. For 12 we can write here 2 2s are 4, 3s are 12. 16 we can write 2 2s are 4, 2s are 8, 2s are 16. We know that how to find HCF. HCF 12 comma 16, in that which are the common? 1 2 is common, another 2 is common, 3 is not common, so 2 2 are common. So we can write HCF of 12 comma 16 is 4. Okay, same way we are going to find the LCM. LCM is what here? LCM of least common multiple of A comma B, product of the greatest power of each prime factor involved in the number. Okay, so see here, greatest power of each prime factor. So we have to include all the common numbers as well as not common numbers in the LCM. So LCM 16 comma 20 we can find by the simple way that 16 we can write 2 2s are 4, 2s are 8, 2s are 16, and 20 we can write 20 equals to 2 2s are 4, 5s are 20. So we have to include the common numbers. Okay, common numbers are 2 into 2, that is 4. So LCM in that we can include 2 2s are 4 is common, as well as we can say that these are also extra 2 are also there, that is 4, and 5 also we have to include. So 4 4s are 16, 5s are 80. Okay. Second thing we are going to prove here that HCF A comma B into LCM A comma B equals to A cross B. Okay, so first we will find the HCF of A 8 and 20, and then after we will find the LCM of A comma B, and then we will prove that 20 into 80 is what? 160. Okay, so HCF first we will find the here A is what? 2 2s are 4, 2s are 8, and B equals to 20, in that 2 2s are 4, 5s are 20. So HCF will be HCF of 8 comma 20 will be common number, that is 2 are common here, so we can write 4. Same way we can find the LCM. LCM will be 2 are common, that is 2 into 2 plus extra 2 is also there, and here the 5 is also there, so we can write 5 here. So 2 2s are 4, 2s are 8, this is 40. Okay, now we are going to prove this one. So we are writing here HCF of A comma B. HCF we got here 4 into LCM of A comma B, that is 40. A we have what? 8, and B we have 20. Say that 160, and 20 into 8, that is also 160. So we can prove the 160 equals to 160, RHS equals to LHS. Dear student, we are going to learn about the irrational number. A non-terminating and non-reoccurring decimal is called an irrational number. Example is given root 2, that is 1.41421356, that is non-terminating as well as non-reoccurring. Same way root 3 value, root 5 value, one value is given here, that is a non-terminating, and non-reoccurring means numbers are not reoccur. 0.101, 001, 0001, 4 times 0 and 1, so they are non-terminating and non-reoccurring. Same way value of pi, that is also non-terminating and non-reoccurring. All are irrational number. If a be a positive integer and p be a prime number and p divides a square, okay, here we have one condition is there, a is positive integer and p be a prime number, then if p divide a square, then we can say that p divides a. Then suppose we take a equals to 2 and p equals to 2, so a square will be 4 and p is 2, so 4 divided by 2 is 2. Let x be a rational number, okay, here x will be a rational number whose decimal expansion terminates. So here it is not non-terminating, it is what terminate. X equals to p by q, where p and q are the co-prime and the prime factorization of q is in the form of 5 raised to n and 2 raised to n, means the number is like what, in the denominator is 5, 10, 25, in the form of what, 5 raised to m and 2 raised to n. Suppose I have to represent 10, then 5 raised to 1 and 2 raised to 1, so m equals to 1 and n equals to 1, where n, m are the non-negative integers. Suppose I take example of 2 divided by 5, so we have to focus on the denominator, okay, so 5 we can write in the form of 5 raised to 1 and 2 raised to 0, so we can represent in this way 5 raised to m and 2 raised to n. In that 5 raised to 1, m is 1 and 2 raised to 0, okay. To get the answer we multiply and divide by 2, so the denominator is become a 10, so 2 is multiply and divide, so we get 4 by 10 and 0.4. Let x equals to p by q, rational number, q is not in the form of 5 raised to n and 2 raised to n, so here denominator in the 3 is present, that we cannot represent in the 5 raised to m into 2 raised to n. Then x has a decimal expansion which is non-terminating, repeating. At this condition, when in the denominator the number is present that is not in the form of 5 raised to m and 2 raised to n, then the whatever the answer will be there, that is a non-terminating, repeating, okay. So this is all about the today's portion. If you like my video, then like and subscribe my channel. Thank you for watching.